went to Grammar Boys High School, and my favourite subject was physics. So I'm a researcher at the University of Sydney, and my focus in engineering, and my focus is on robotics, and in a particular area called field robotics, which means robotic systems that have to work outdoors. Typical day would start early in the morning. I'd probably get into work at about 7, and it usually involves looking at my meetings for the day first to kind of see what's coming up, possibly answering some urgent emails and planning out research technology pathways. The meetings are usually with other researchers, so other researchers and engineers that work for me in the projects that I have, and we talk about upcoming activities, milestones, and where the research is going, or innovative aspects of the research. And we'd be talking about anything from what technologies we're building, where we're demonstrating it, and how are we publishing the results. So my focus is on field robotics, so that's outdoor machinery that has to work 24 hours, 7 days a week, and one of the large areas of work that I work in is in agriculture, and what that means is designing technology, again, sensors, software, algorithms, hardware, robots that have to work on farms. They can work on different types of farms, so vegetable farms, grain farms, cattle farms. And for each one of those, they have different requirements. Some are more harsher than others, and so you have to understand how that technology can be adapted to work in that type of environment. And at the same time, you're talking to farmers to understand what their pain points are and where you think the research might help address some of those pain points in, say, 5 years. So unlike a company which might be, or a business that's trying to solve their problem now, our focus is where is the future of ag going, and how can robotics help them with that. So we design and research new technologies by talking to farmers and understanding their environments, and building these technologies, taking them to a farm and testing them out on farm and adapting it. When you're working in agriculture, you're dealing with very large landscapes, and so you're making decisions based on a very coarse piece of information, what's happening on my paddock or what's happening across my whole farm. So where robotics comes in is the ability to kind of traverse over a farm or go over a farm in very high precision. So you can now start to sense individual plants down to individual centimeter of the soil. And you can also do very precise tasks like remove a weed that's only 1 centimeter wide amongst vegetables, or follow or track an individual cow, for example, across the landscape. Now with robotics, we can solve some of their labor problems, and now with some of the sensing, we can solve some of their information issues, but also now we can become a lot more environmentally sustainable because we can do things a lot more precisely, such as how much fertilizer to spray and where to spray it, down to the plant level, or just remove these weeds and minimize how much soil disturbance there is. And they're just some of the examples of things that can change. Roboticists, we're systems thinkers as engineers, so we piece together many different elements. We piece together sensors and software and hardware and robots and algorithms, and we have to test it out in the field. And usually it's a very unique type of engineering that you work in, because you have to kind of bring all these little components, componentry systems together. Generally, when you're working with other industries, you generally are solving a problem for them, and it's a very specific problem. And what surprised me the most was working with farmers who very quickly I learned that they're also systems thinkers. They have to worry about what's below the soil, what's above the soil, what happened with the weather yesterday, what's happening with the supply chain tomorrow. And so they have this connection of elements, and so in working with farmers, you kind of resonate very quickly with them, because you're both systems thinkers, and so they end up being the best type of critics basically for the technology you build, because they very quickly can identify where the technology will and won't work, and help you kind of progress that technology very quickly. Early on, it was technical strength, so being very knowledgeable as well as practical in a particular type of technology, whatever that might be, in the early part of my career. So that was really about being able to solve problems using the skills that I had, doing so effectively. As I moved into the middle of my career, it was about engaging with external stakeholders and building a team. So engaging with non-researchers, finding out what their problems were, and trying to build a team that would help solve their problem and work with them. And I guess now in my career, it's more about people management, right? So it's more about there are other researchers now who want to do the same thing. How do you work with them? How do you help them grow in their field? And also engineers as well, who want to kind of progress in their field. So it becomes more and more about people management and project management and mentoring people along the way. So in my particular area, because it's research driven, it requires a lot of focus for long periods of time. You might be sitting on a particular mathematical problem for 3 weeks, and that's just one problem, and you've just got to keep working on it and trying to play gymnastics with the maths and going backwards and forwards to try and solve it. Or it could be a technical problem where you're writing a piece of code and there's a few lines in that code which aren't working properly, and you might be spending 2 weeks just trying to solve that particular area. Or you need to go out into a field trial where you're spending 5 days out in the field to kind of solve a particular robotics problem. So all of that requires a lot of focus and dedication. Generally, what I find with the younger folk that come through is that that's a little bit lost. They're a lot more, they want information a lot quicker, and they want to solve problems a lot quicker, which is nice to have, but it's not necessarily something that kind of works that well in research. So generally what that means is being able to kind of remove distractions. This is how they overcome and remove distractions around them, being able to kind of find a time where they can devote some focused energy into whatever it is that they're trying to solve. So I predominantly, when I'm in the office or in the area that I'm wearing, I wear an ASICS sports shoes, and because I'm running around between meetings, walking around between meetings, you just need something comfortable, and doing that. If I'm in the lab, it has to be closed shoes, so the ASICS is okay for that. If I go out to the field, I'm wearing boots. I need to kind of do that. And then when I'm presenting to farmers or researchers, I'll have to put some shiny black shoes on. So I kind of switch the shoes around depending on what I'm doing.